We're going to talk about now linear functions and nonlinear functions. Basically, a linear function, and I just highlighted in green with the yellow, is that as long as you only have addition, subtraction, and multiplication of a variable that's not being multiplied together or in a denominator. So right here is where it cannot be. So we're looking for variables that are not in a denominator and not multiplied with another variable. As long as that happens, it's a linear equation. So here's some examples of those. We want to take that and apply that to our problems we have here. So our first problem is say whether it's a linear function or not. So I'm looking for letters in the denominator. There's none, and there's no letters being multiplied. So this is a linear function. If we look at this next example, B, there's a variable in the bottom, so this is no division, and the reason is division of a variable. Now, if we look at our next problem, letter C here, we have two variables being multiplied, so this is also no, it's multiplication of variables. So these are the reasons why you would not be. Then we look at our next problem, we have a variable in the denominator, so this is also no division with a variable. And then our last problem can be tricky because we have fractions, but the variable is in the denominator. It's right here. It is part of the numerator, actually. So this is a linear equation. So now we want to evaluate or find the answer to a linear function. So we're given this linear function right here, and then we want to figure out what the variables stand for. F of x is the total height, and x is the days. So when we look at our problem, it says how tall is the sample after 3 days? It gives us the days, so it gives us x. Because it gives us x, we can put it into our function. F of x equals 5.9, and I'm going to put 3 in. Let me erase this so it's a little bit better. Equals plus 3.25. And if you just take your calculator and do that math, 5.9 times 3, and then add 3.25, you get 20.95. So we want to know how tall the grass was. Well, the f of x equals 20.95. So the grass was 25.95 inches tall. So let's look at our second example. Same thing, but this time they tell us how tall the grass is, and we want to know how many days. So this time we're using the 50.45 into our function equation, but the 5.9, and we don't know x. We want to figure it out. So now we're going to solve our equation by subtracting our 3.25. So if I subtract the 3.25, subtract 3.25, then I get 5.9x, and then I divide by 5.9. And if we do our calculation in our calculator here, 47.2 divided by 5.9, we end up with 8. So x equals 8. So the answer to the question is 8 days. So now we're going to look at what's called standard form. Standard form is a format where we have ax plus by equaling c. This number always needs to be positive, and we have no division or no fractions in our problem. So what we want to do is look at the number in front of x, make sure it is a positive number, and the number in front of y makes no difference, and then we have it equaling a number without the variable. So we want to look at here's our first problem. We want to put that in standard form. The very first thing we want to do with standard form is get rid of fractions. To get rid of fractions, I'm going to multiply everything by this denominator right here. So if I multiply, so let's rewrite the problem. And I'm going to multiply everything by that denominator. Doing that on the first part, we get rid of the denominator. And then I get 80y, and then I get 150. Now, we always want the x to be positive. It's negative now, so if we look at that, I just want to highlight that. This is negative. I'm going to move it over to the other side. So I'm going to add the 3x to this side. But at the same time, I need to also move the constant. So this part needs to be moved to the other side. So I'm going to add it to both sides. By doing that, this part cancels. And so we end up with, let me just write it here, a 3x plus 80y, and it equals 150. So because these two are on the same side, and the 150 is opposite, we end up with our standard form. And then the question is identify A, B, and C. Well, A is the 3, B is the 80, and C is the 150. Okay, let's look at our next example here. We have a 2y equals 4x plus 5. So I have no fractions to get rid of, but I have my positive. So I'm going to move the y over to this side, and I have to move the 5 over to this side. When you move something, you just change the sign. So I get a negative 5 equals 4x minus 2y. And so this is standard form. Even though I have the c on the left-hand side, we can switch it around to make it equal to the negative 5. It doesn't matter which side it's on, but now we have it in standard form. And so here's A. Here, the negative 2 is the B, and the negative 5 is the C. Last problem we want to look at. We have the letters all on one, numbers all on one side. So I need to get rid of the constant. And so I'm going to add 9 to both sides, or move it over. So I have 3x minus 6y equals a positive 9. So my A is the 3. The negative 6 is the B, and 9 is the C.